Can you also tell a bit of difference between general purpose robotics and the approach that's there behind it, and the narrow AI way of dealing with robotics?
Yeah. Well, the general AI concept is to build machines so that can apply different type of models to different tasks, right? And to some sort of limitation, we can build robots that can be okay. For example, in industry, these robots were pre-programmable. So that means that you sell the same type of robot, but it
Yeah.
can do many different operations. But typically in the industry, what you have is a line of robots, the same type of robots, but you have a line of them. Each of them does a particular task. Okay, so although you are selling one robot that ideally could do several operations, um, when in practice, you what you want to have is a robot that is set up in a particular place to do a particular task or one or two tasks,
Yeah.
not many. Okay? Um, well, that also it's because efficiency and stuff like that. But if you consider, for example, a robot manipulator that can do several operations like painting or screwing stuff and whatever, well, doing that with a human hand, right, is going to be very difficult. So what you prefer is to have a specialized tool attached to the robot arm that
Yeah.
does that particular operation. So it's better to have two robot arms, one with the spray to paint the car, for example, and the other with the screwdriver that can screw things
Yeah.
on the car. So instead of just swapping around the tools. And if you think about a robot that wants, you want a robot to work in your house and do all the tasks that a maid would do, well, doing it with two humans' hands is going to be very difficult. So what you want is actually specialized robots that are able to do some particular task. And right now we are at the point where there are robots around the house, like the dishwasher,
Yeah.
the washing machine, the coffee makers. They can be seen as robots. They do a particular task, right? And you can have uh, all these robots connected together, working together, and you can control the robots. You can control the thermostats of your house from your cell phone, right? So you can pre-program some particular timing for doing the action. So you activate in you can schedule the activation of these tasks, right? Um, but because they are specialized robots, they know how to do that particular job, and they are designed not as humans, but they're designed as the with the best design to accomplish that particular job. So
Yeah.
the washing machine is just a cube where you fill clothes inside. It's not a humanoid robot that goes to the river and start, putting your clothes into the water, right? So
Yeah.
that's how we design a specific robot for particular actions. Obviously, from the research point of view, it's very interesting to be able to build a humanoid robot that is more capable of doing things, right? Our goal for the research is not to build a robot that looks like human, can fool humans and act as human, right? Is um, the the human design is taken for some particular purposes because it's easier also for us to encode to represent particular task if we have some particular design like the one we are comfortable with, like for
Yeah.
example underwater robots that needs to pick objects from the seafloor or do some operation of restoration under a boat, for example, or wherever. Um, well, if I have to design a robot like that, I will design it with the two arms, right? Because I know that if I needed to do some assembly task, perhaps one hand is not enough. You need support with the second, and
Yeah.
you know maybe having three could be also useful for particular situation. But I know that with two hands, I can actually do most of the stuff I want to do because as human, I'm interacting with my world with two arms. So that is actually the reason why sometimes we tend to design robots as humans, not because they need to, but because we know, you know, why that design works because we're using it all the time, right?
Yeah. Yeah.
But yes, to go back to your questions, generally, I don't want to say as lost interest, but is nowadays more a theoretical point of view, is a theoretical investigation if it's possible to actually generate different behavior, how to combine behaviors. But most of the robotics they are actually working on real problems. They
Yeah.
tend to specialize the robot. They perhaps use the same robot and try to accomplish different tasks, but it's difficult to see a robot that, although you have developed the same task on the same robot, it's difficult to see a robot that then combines all these tasks and executes all of them. Okay, so you have
Yeah.
one specific set of algorithms that enable the robot to do a particular thing, and then you have another set of algorithms that enable the robot to do something else. Okay, and
Okay.
in that way, you can evaluate design, you can evaluate algorithm, you can evaluate the if the ability of the robot has grown and got went behind the state of the art of yesterday. And but typically you need to create models, you need data to create these models, you need a lot of information to keep around. And if you start adding multiple tasks on the same robot, then you ended
Yeah.
up that you need big spaces for your data, big time for your processing, and that's something we can't really do right now. There are a lot of research on long-term, long-life robots. Like, for example, if you think a robot that has to work in a hospital as a service robot, uh, well, ideally that robot should work constantly, 24/7, right? So he needs to be able to, you know, learn new things, specialize to the particular hospital he's working on, if they're, memorize where the reception is, where the rooms are, where the service rooms are. And these things, you don't want to lose it over time, right? So you need to, by a certain point, you will get so much data, you need to figure out what data I can lose without actually losing knowledge.
Yeah.
So that's another problem. Trying to compress data, combine data, lose the data that you know will not make the difference. Okay, so that's where we are, and there are a lot of projects, especially one that comes to mind is Nick Oves at the University of Oxford. He's working on this area. They're making a great progress, but still, we don't have. Robots that can work for years without never being, required any help from the operator.